All right. So for section 6, more factoring and graphing, we're going to do the exact same thing we've been doing, but we're going to mix some of our methods together. So you're going to have to decide, okay, how do I get my graph? And we're going to throw some curveballs in here, some weird things. What happens if it doesn't work out nicely? What happens if we get something strange like this? So everybody, phones away, earbuds out, focus up here, and let's get started. For number 1, it says factor each completely over the integers. That's important. We're not going to factor into weird factors that are not integers. However, we are going to find all of the roots or zeros, and then we're going to make a sketch. So here we go. Remember to label the intercepts as we go. How am I going to factor this? What did we, oh, go ahead. By grouping, right? We have 4 terms. 4 terms, let's try grouping. If that doesn't work, we could maybe try something else, but probably 4 terms, check the first 2, check the second 2, see if it factors by grouping. So if that's what I'm starting with, what do you see in the first 2 terms that they share? An x squared is exactly right. So for these 2, you can take an x squared out. X squared, I'm left with x plus, what do I put there?
1.
And I left something, yes, I'll give you extra credit. You were faster than I was. 2x, sorry, that 2 is still there. And then this was the part I was focused on. What do I put there when I take everything out? A 1. 2x plus 1. 32x plus 16 now. What do I do with those 2? Does everybody agree I can take a 16 out of those? So plus 16, left with 2x plus 1. Good stuff so far. Everything's working exactly like it did yesterday. Got the exact same 2 parentheses. Take those out. 2x plus 1 times x squared plus 16. And then do I have a difference of squares? Oh, look again. What does difference mean? Subtraction. That is not a subtraction problem. So the reason they said factor over the integers is that there is a way of factoring this, but not with regular numbers. We're kind of stuck right there. That's factored as far as it goes. But I need to find the zeros. So remember, okay, we're going to go back a step. We've been rocking this, going so fast on a lot of them that we're just saying, okay, x plus 3, that's a negative 3x intercept. We're not even bothering to set it equal to 0 anymore. But when you get something weird like this, we're still going to set it equal to 0, and we're still going to solve. So this 2x plus 1, 0, actually, let's keep the color coordination going. 0 equals 2x plus 1. How do I solve that for x? Subtract 1, right? That's exactly right, Allie. Negative 1 equals 2x. And then the latter, divide by 2. So here, for the first time, we're getting an x-intercept that's a fraction. X equals negative 1/2. Now, yeah, it's a fraction, but I can still graph that. I can find negative 1/2 on my graph. So I just come down here and say, okay, here's 1, negative 1. Negative 1/2 would be right about there. So there's one x-intercept. X squared plus 16. Let's take that one. X squared plus 16 equals 0. How do I solve this one? Subtract the 16. X squared equals negative 16. What's my next step? Square root. That's exactly right. Is everybody good? X squared. I need to get rid of the squared. Square root. Square root. X equals plus or minus the square root of negative 16. What do I do with the negative square root? It's imaginary. So I'm going to put a little I there, right, to hold the negatives place. So plus or minus I. And then what's the square root of 16? 4. So actually, I should write this as plus or minus 4I. Now, do I have everybody's full attention? Write it down, get it all copied. Plus or minus 4I, those are two roots, right? A plus 4I and a negative 4I. But 4I does not exist on my graph. Does that make sense to everybody? It's a solution, it's a root, it's a 0. It's not an x-intercept, okay? So when I go to graph this, what's going to happen, I'm going to get my y-intercept and my end behavior. So I'm going to go back up here, plug in 0, 0 plus 0 plus 0 plus 16. So I'm going to have a y-intercept at 16. Actually, let's use a different color so we don't get that confused. So y-intercept at 16, y-intercept at 16, and then end behavior, 2x cubed. What's the end behavior? Turn to the person next to you, tell them what the end behavior is. And don't trust them. Make sure, are they right? Are they telling you the right thing? So I was hearing different answers. What do you guys think? What's the answer here? What's the end behavior? Low, high. I was hearing a few people say high, low. And again, that would be for negative. That would be ending low. For a positive, we want to end high. So low, high here. When I graph this, it's going to look a little odd. Essentially, what's going to happen, and without more information, it's hard for me to tell exactly what's happening, okay? I would have to use a calculator to really get this. But essentially, my graph's going to look something like this. It's going to be coming up, and it's going to maybe like do a little zigzag, do a little down like it was going to make some more x-intercepts, but it's not going to make it. It's not going to get to the x-axis. Does that make sense to everybody? So let's check. I'm curious for this one. If we go to Desmos, and we put this one in, somebody read me the original equation. It's y equals 2x to the third plus x squared plus 32x plus 16. Okay, we can't even see this. Let's zoom out. Zoom, zoom. Yeah, this one does not end up like, you can't even see that little dip that I drew in there. At least not with these terms. Let's adjust one more time. Actually, no, let's leave those on there. Let's make this go from -10 to +10. But let's zoom out on the y-axis. Let's make this -100, +100. So if I zoom way out, you can see a little bit of that curve happening. I over-exaggerated it when I drew it. You don't have to worry about that. What I'm going to look for on your graph is that it's not a perfectly straight line, but it's maybe a little curve, and that you hit those 2 points, the x-intercept and the y-intercept. Does that make sense to everybody? Okay, and I think I forgot to switch this. So those of you that are watching online later, here is what we found when we graphed that with Desmos. So again, you see our x and y intercepts and a little bit of a curve. So now they're going to ask us, actually they didn't. They just said find all of its roots, zeros. So somewhere we need to label our roots or zeros. I'm going to write it off to the side here. Roots or zeros. Our roots or zeros were -1/2, 4i, and -4i. Is everybody good with plus or minus 4i being two roots, plus or minus? And then of those, only one is an x-intercept. This guy right here is our x-intercept. Do we have any questions so far? Yes. So you're asking, like, so this one had imaginary numbers. Are you asking if my graph had imaginary numbers? Or what? So tell me your question one more time. Are you sure? If you want to ask it at some point, let me know, okay? Because this is kind of weird, right? This is the first time we've had things. I keep telling you that roots and zeros and x-intercepts are all pretty much the same thing. This is the first time where we're really seeing that there's a difference between the x-intercepts and the roots and zeros. So let's try another one. Number 2. We see 4 terms. That's weird. They put the terms out of order. Let's try factoring by grouping still. Let's see if it works. 2x cubed minus 16x. Well, looks like I can take a 2 and an x out of both of those. So 2x times x squared minus 8. 3x squared minus 24. Looks like I can take a 3 out of those. X squared minus 8. Okay, so far so good. I've got matching parentheses, so I can take those out. X squared minus 8. X squared minus 8 was multiplied by 2x, and it was multiplied by 3. Is everybody good with that? Just like we were doing yesterday. The problem here is going to be this guy. It looks like a difference of squares, right? It is subtraction this time. But that 8 is not a squared. Does that make sense? 8 is not something squared. This is, again, where it said only over the integers. So while there is a way of factoring this, we're not going to do it. We're going to say that's not a difference of squares. It doesn't work out nicely. We're going to leave it like that. Welcome, come on in. This 2x plus 3. That one I can solve just like normal. 2x plus 3 equals 0. Subtract 3 from both sides, minus 3, minus 3. 2x equals -3. Divide by 2. X equals -3 over 2. X equals -3 over 2. There is a value that I can put on here. We can even just mark it and say, okay, this is going to be -3 over 2 right there. That's going to be one of my x-intercepts. What about that x squared minus 8? X squared minus 8, I can set that equal to 0. X squared minus 8 equals 0. I can add 8 to both sides. X squared equals 8. I can take the square root of both sides. You doing okay? Take the square root of both sides. X is equal to plus or minus the square root of 8. That simplifies. X equals plus or minus. So 8 is 2 times 2 times 2, right? I'm not going to make the factor tree this time. I know it's 3 2s. I can take out one set of 2s, leave one inside. So plus or minus 2 root 2. Can I graph that? If you have a calculator nearby, which I stole all the ones from the first couple couple groups. Can you take the square root of 8? Everybody, if you've got a calculator nearby, go ahead and try. Take the square root of 8. What's the square root of 8? Something about 2.8. Is 2.8 on my graph? Now, if you have one of these calculators, there's two different sets of calculators in this class. You got these ones and these. The ones that used to have the silver on them, they have a little plus or minus button at the bottom. This one will do negatives, but there's just not a plus or minus button on it. If you got one of the silver ones, or those used to be silver ones, if you try to take the square root of -16, or if you have the other ones, you could do 0 minus 16, get that -16, and then hit the square root key. What does it tell you? Still E down at the bottom for error. This one does not have a real answer. That's why we had to put the I on it. That's why it doesn't fit on our graph. The plus or minus 2.8 does. Okay. So I'm going to come down here. 2.8 is negative 2.8 to the left or to the right of -3n/2? To the left, right? This is negative 1.5 essentially. So I'm going to come over here, put another dot, and say this is negative 2.8, and another dot over here at positive 2.8. Or better yet, just call it 2√2. That would be the exact answer. Negative 2√2 and positive 2√2. As long as it's labeled with one of those two, you'll get credit for it. Okay. I need to see this. I need to see you taking the square root of 8. But if you use the 2.8 after that, that's okay. All right. So now let's get the y-intercept and the end behavior. Negative 24. Right. That negative 24 is my y-intercept. And then end behavior, 2x cubed is low high again. So I'm starting down here, up, back down, get all the way to that one and back up. Again, make sure everything's labeled. Mine's a little bit messy because I have multiple labels on some of them. But there is our answer. I want you all to try one now. Everybody go to the homework. Open up the homework, section 6. And I want you all to try number 1. Everybody try number 1. So we're going to go through factoring this one from the homework. So Jason, what do these two terms have in common? The 3x cubed minus 7x squared. An x squared is perfect. So you take that x squared out, leaving us with 3x minus 7. From the second set. Logan, what do you think we can pull out from the second set?
Positive 4.
Yeah, and so what's left inside?
Inside is 3x minus 7.
Perfect. So again, we've got our two sets of parentheses that match. So Faith, how do I write this factored now? X squared plus 4. And that is fully factored. Does that make sense to everyone? That x squared plus 4 does not factor anymore because it's not a difference of squares. So instead, we solve both of them. Bao, did you get a x-intercept or a solution for this? Hopefully, as you get more and more comfortable with this, you won't have to set it equal to 0, just like you were doing before. You can just take this and say, okay, well, add 7, divide by 3, 7 over 3. Are we good with that? If you need to set it equal to 0 to solve, that's fine. but you can hopefully start to get straight to there. 7/3. What about that x squared plus 4? Emily, what do we do with that x squared plus 4? There we go. So x squared plus 4 equals 0. Did you subtract the 4? Yep. So x squared equals -4. So what did you get for your final answer for those? Plus or minus 2i, right? If I take the square root of -4, square root, plus or minus 2i is correct. Can I graph imaginary numbers on this? Not on this graph. There are no imaginary numbers on here. So I have one x-intercept at 7/3. Now both of these sets, this is 3 zeros, 3 roots, but only one x-intercept right here at 7/3. Let's get my y-intercept. Not here. We got several people out for the PSAT. Find someone that is still here. Brianna, did you get the y-intercept for this? -28, right? Just straight off of the original equation, -28. Then we need our end behavior. Jordan, what's the end behavior for this one? Low, high. So I start low, come up, just make it a little bit of a curve. Just don't draw a straight line. Does that make sense? As long as it has a little bit of a curve, you're good. So we have our 3 zeros, but only one x-intercept and graph. All right, let's go back to the notes. Back to the notes here. We've got a few other strange things in here, but like that's probably some of the hardest stuff that we're going to do. Actually, there's one other one that's going to be a little rough, but let's try it. So number 3. Everybody look at number 3. G times h of x. G times h of x, given x squared minus x minus 6, and 2x squared minus 5x plus 2. This is just telling us take these two and multiply them together. X squared minus x minus 6 times 2x squared minus 5x plus 2. We're just multiplying the two of them together. Do I put this x on the end? Is it times x? No, that x is just telling me that's the variable. Okay, I just need g of x times h of x. Now, do not multiply them together. We're trying to factor it, right? If you multiplied it together, you'd be making your life so much harder. It's already halfway factored for you. We just need to factor these two. Both of them factor quite nicely. Can anybody think of something that multiplies to -6 and adds up to -1? Okay, try again. So 2 and 3, which one's negative though? I want it to add up to -1. The 3 is negative. Does that make sense to everybody? So x minus 3, that was a good team effort there. We had several of you contributing. X plus 3, x plus 2. Double check it. -3 times 2 makes -6. -3 plus 2 makes that -1 in the middle. So that one's factored. Next, this one does have a 2 out in front. So we're going to have to do guess and check. 2x times x. What's the only way to multiply to make 2? Right, 1 and 2, 2 and 1. And if I need it to end up being a 5 negative, it's probably going to need to be both negative. Does that make sense? So I'm just going to guess -2, -1. If I multiply this together, I get a -2x and another -2x. Shoot, that only makes -4. Not good enough. So I'm going to try again, and I'm going to switch them. -1, -2. 2 times -2 makes -4. -1 times x makes another -1x, which makes my -5x. You must check if you're doing guess and check. You must make sure that it actually works. Can I get x-intercepts from all those? Yeah, just shout it out. X minus 3, what's the x-intercept? 3. X plus 2, what's that one? -2, okay. This is the one where you might want to set it equal to 0. Add 1, divide by 2, what's the x-intercept? 1/2. And then here, x minus 2, what's the x-intercept? 2. There we go. Put them all down. X-intercept at 3, x-intercept at 2, x-intercept at 1/2. Try to space them correctly. If you want to make little hash marks and actually do 1, 2, 3, 4, 5, and then put the points on it, that's fine. I just need to see it labeled, and it needs to be in the right order. And then -2. Yes, go ahead. So now, last thing I need, y-intercept and end behavior. How am I going to find the end behavior for this? Anybody have any ideas? So I really don't want to multiply everything together, right? That would take a long time to do that 3 by 3 multiplication. Which ones are the most important? Yes. Yes, the highest degree from this one, highest degree from this one. And I should use a different color, make that a little bit more obvious for you. X squared times 2x squared makes 2x to the 4th. So what's my end behavior going to be? Even positive, which means high, high. So again, high, high. Last thing I need is the y-intercept. Now, anybody know how I can get the y-intercept without multiplying everything out? Can I do kind of the opposite of the shortcut I just did? Can I take the ones without it with the least degree, degree 0? -6 times 2. Would that work? If I multiply it all the way out, is that the only thing that's going to not have an x in it? So that's going to be my y-intercept. Or if that doesn't make sense, you can just plug in 0 for x. 0 minus 0 minus 6 would be -6. 0 minus 5 plus 2 would be 2. -6 plus 2, or sorry, -6 times 2 is -12. -12. Let's connect the dots. So I'm going to start up, come down, up, down, up. Something like that would be our answer. Any questions on that one? All right, here's an easier one. Let's do number 4, and we're going to do it pretty quick. 3x, 24, 3x to the 4th, 24x. I lied, this one's not easier. 3x, x cubed plus 8. Oh, man. That's a sum of cubes. That's what we did last week, last unit. I'm going to show you this one time. Okay. We did sum of cubes last time. At most, it's going to show up on the test once. Okay. There's not going to be a ton, but you should still know it from last unit. So that x cubed plus 8 is x cubed plus 2 cubed, which factors into x plus 2 times x squared minus 2x plus 4. And again, you have to know how to use the formula. It's back there on a poster. I'll put it up on the board for you. We gave it to you last unit. I'll give it to you again this unit, but you have to know how to use that formula. Anybody remember what always happened with these? What was that? So yes, this is SOAP as far as the terms, positive, like same, opposite, always positive. But this piece right here, we always had to find imaginary roots from that using the quadratic formula, because that is not going to factor. Does that make sense? So if I'm looking at this one, x squared minus 2x plus 4. All right, I'm going to do a is 1, b is -2, c is 4, x equals, try to make it nice and big for you guys to see, x equals minus b, so 2 plus or minus the square root of -2 squared minus 4 times 1 times 4, all divided by 2 times a, so 2 times 1. Two plus or minus the square root of 4 minus 16 all over 2. Four minus 16 is going to equal -12. That -12 is inside my square root, so it's going to be an yes. Because the quadratic formula is x equals minus b, the opposite of b. Does that make sense, Brian? Yep, so plus 2 or minus -2. -12 is going to be an I. 12 is 2 times 6, which is 2 times 3. So I have a pair of 2's. So 2i root 3. 2 plus or minus 2i root 3 divided by 2. 2 goes into both of those. I end up with 1 plus or minus 1 I root 3. Can I graph that? So again, imaginary numbers do not show up on our graph. Those are my roots. Those are my zeros. They are not my x-intercepts. Yes. So because it's all together, this is technically one number. It just has a real and an imaginary part. That's much more of stuff you get into advanced math next year, where they talk about the idea of that complex number having both a real and an imaginary part. But because it goes together, I can't just graph part of it on this graph. Does that make sense? It'd be like saying 2 plus 3, I'm just going to graph the 2 part. That's not the whole thing. 2 plus 3 is 5. I need the whole thing to graph it. Does that make sense?
Yeah.
So can't graph that one. It's a root and a 0, but not an x-intercept. But I have some x-intercepts, right? Let's go back up here. I have x-intercepts at 0 and -2. Does that make sense to everybody? 0 and -2. So I'm going to put those down. Here's 0. Here's -2. Get my y-intercept. Wait a second. I have my y-intercept, right? 0, 0. So all I need is the end behavior. Looking back up here, 3x to the 4th. Okay, it's even. That x to the 4th is even, so it's got to be the same. So high. Does that make sense?
Oh, yeah.
Because the x to the 4th is even and it's positive. So high. So I'm going to start, and it's going to look kind of like a parabola. Again, technically, it's going to do some interesting things. It might have like a little bobble somewhere. It might go like a little W, but with half of it above the x-axis. I'm not going to expect you to find that. I just need you to see the x-intercepts, the y-intercept, and the end behavior. As long as that matches, we're going to call it good. Does that make sense? Now, real quick, we're going to do one of these, and then we're going to be done with this section, okay? Graph touches the x-axis, so turn to number 5. Graph touches the x-axis at -2 and 3. What did we say touch means? What's another way of saying that? Bounce. It's an x-intercept, but you're right, but it's a bounce. Does that make sense to everybody? Okay, so -2, bounce, +3, bounce, goes through at x equals 1. So here's another x-intercept at 1. Y-intercept is -12. Remember how for these, I don't really know what the end behavior is until I graph it. So I'm going to start at the y-axis, the y-intercept, up, bounce, and up. And then over here, up, bounce, and down. So I went through at 1, I bounced at -2 and 3, and I hit my y-intercept at -12. They want me to write the equation for this. So I'm going to say, all right, y is equal to, let's get some factors here. If my x-intercept is -2, what's my factor? Does that make sense? I'm hearing it here and there. Everyone that's saying it is right, but I'm only getting like a quarter of you. Are we good with it being the opposite? Y equals x plus 2, and then a couple of you figured out it was a bounce. So we're going to square it. X plus 2 squared. Put that a out in front. Then how about the x equals 1? What's my factor for that one? X minus 1. And the x equals 3. X minus 3 squared. That is an equation, right? It's the general one. I need A. It wants the actual equation. So I'm going to plug in -12, 0, or sorry, 0, -12. 0, -12 here to find A. So right there, I'm going to put in -12 equals 0, 0, 0 for all the x's. So let's clean that up. -12 equals A times 2 squared times -1 times -3 squared. 2 times 2 is 4 times -1. -3 times -3 is going to be 9. So I end up with -12 equals A times -36. Divide both sides by -36. And we end up with an A value of 1/3. So my final answer, full equation, y is equal to 1/3 x plus 2 squared, x minus 1, x minus 3 squared. There's my final answer. Now, class, I know that these problems are long and difficult. So we are not doing all of them. We are doing 1 through, I think I said 11. I'll double check it, but 1 through 11 odd. And I already did one of them for you. We already did number 1, right? So I'm going to give you guys 10 minutes to knock out another couple, okay? So let's get started. 1 through 11, I'll double check, but I believe what I wrote on the website was 1 through 11 odd.